Section 1.6, Graphical Transformations. So the first thing we need to talk about is we have these 12 basic functions that we talked about in an earlier section, that a lot of the functions that we have are really just based on these 12 basic functions with transformations of some sort. Like if I take the cosine function right here and I move it up 3 units and then I draw it again, I've transformed that graph. Or if I not rotate, but if I reflect something across the x-axis, that's a transformation because I'm changing the graph from an original graph. And so you should have in your notes, or they are in the book, these 12 basic functions. I just wanted to make sure we all knew what I was talking about when I talk about basic functions, like the basic identity function is y equals x. The basic squaring function is y equals x squared, and so on. So that's what we're going to start with, and then we're going to talk about the transformations we can do to those graphs. All right, so we've got two types of transformations. The first type is rigid transformations, which do not change the size and shape of a graph. It's just when we have a vertical or horizontal shift, or if we have a reflection. And so it's like we could take that shape of the graph and the size, and we could pick it up and move it, or we could pick it up and reflect it because the size and the shape aren't changing. Non-rigid transformations are where we do change the size or the shape of the graph, and we do that by using vertical or horizontal stretches or shrinks. So those are the things we're going to talk about today. All right, so the first thing is translations. Translations, that's a fancy word for shifting a graph or sliding a graph. A vertical translation, we take what our original function is, like if we're talking about the squaring function, f of x would equal x squared. Whatever that original function is, if we add a number to it, then that's a translation of up c units, however much we go up, or however much is right here is how much we go up. If we have something like x squared here and then we subtract a number, then we're saying that it translates down by c units. And then here we have horizontal translation, which is going to kind of be an opposite situation. If I have a function like x squared, that's what f of x equals in my example right here. That should not be there. F of x equals, now I'm talking about x squared. Then for vertical translations, I'm just adding or subtracting a number out to the side here, and it changes my y value. For a horizontal translation, I'm actually going to put the number inside of a parentheses with the squared on the outside, and I'm doing whatever the opposite of this number is. Like if I have a -2 here, I'm not going -2 on my x, I'm actually going +2. Okay, so not -2, I'm going +2. It's the opposite sign. Okay, so a -c is to the right c units. A +c is to the left c units. Okay, so what we're going to find out is that if the number is outside, it's an up or down translation, and it's exactly what we would think it is based on the sign. If it's inside of a function, like it's inside parentheses or underneath the square root or inside absolute value, then it's the opposite of the number that's in there. So instead of -c, I'm going to think about what +c would be. Like that would be right c units. All right, so let's look at an example where we're trying to translate. This example says, describe how the graph of y equals the absolute value of x can be transformed to the graph of the given equation. So we just need to say, basically from the previous slide, what is going on here. This is my function. This right here is my f of x. Okay, I am subtracting 4 from my function, my original absolute value function, which means I am shifting down 2. or that I've shifted down, not 2, I don't know where 2 came from. I've shifted down 4 because it's a negative 4. Okay, so that would be my answer on that. For part B, my f of x is still this absolute value of x. And so what I'm doing here is I'm adding 2 inside my function. So instead of thinking about plus 2, I need to say, well, I'm going to the left 2 because it's the opposite of what we'd normally think of. Plus 2, the opposite is going to be shifted left 2. Okay, and so that's all we would do on those is say what kind of shift is happening there. The next type of transformation that we have that's also a rigid one is reflections. A reflection across the x-axis is where I have a point xy and basically I'm changing the sign of the y value. And so when we're plugging that into an actual equation, what that looks like is y equals negative of whatever our function is. And so like if you have a square root of x function here, the negative would be on the outside because we're really changing the y, but we're moving the negative over to this side, so it's outside of our function. I forgot to draw this arrow here. So a reflection across the y-axis is going to change the x value. And so we are literally going to take what the x value is and make it negative. So that's inside of my function. So if I have square root of x, it's going to put the negative inside the square root of x. And it's going to be a reflection across the y-axis. So if you notice, these are opposites. That reflecting across the x-axis is actually making my y negative. Reflecting across the y-axis is actually making my x negative. Okay. Got a little carried away there. There we go. Okay, so let's look at an example of how we can work this out in an equation. It says find an equation for the reflection of f of x equals 5x minus 9 over x squared plus 3 across each axis. So if I want to start with, which one did I start with last time? I had the x-axis first. So I'm going to start with reflecting it across the x-axis. And so to do that, I am going to put a negative in front of my f of x. So it's really like I'm saying I'm negating what f of x was. I'm making it negative. And so if I actually want to figure out now what my new f of x is, then it's going to end up making the opposite side negative. So that I really have a negative in front of my fraction. Now if I don't want that negative to be in front, if I want to make my fraction reflect that that negative is there, what I can do is I can either give the negative to the top or I can give it to the bottom. I wouldn't give both of them the negative because that's not the way a negative works. If I had 2 negatives, it'd be positive. I only have 1, so I'm going to give it to the top and say that this is really like 9 minus 5x over x squared plus 3. Okay, so that's if I reflect it across the x-axis. If I reflect it across the y-axis, that means I'm changing x to be negative. Okay, so if I'm making x negative, I'm actually quite literally plugging in a negative x. So 5 times negative x minus 9 over negative x squared plus 3. And then I want to simplify this based on what I know about negatives. 5 times negative x makes that negative 5x. Doesn't change the 9. And then on the bottom, a negative x squared is going to become a positive x squared plus 3. Okay, so this is my answer on this one. I did not mean to put that there, that dot. Okay, so these are two different equations that we have. We have 9 minus 5x over x squared plus 3, and we have negative 5x minus 9. That's not the same thing. Those are two different equations, and they will give us the two different reflections. All right, this is going to be the end of part 1.